Namaste students. In the last class we were studying about continuity and discontinuity. In particular, in the last class we have studied about the continuity of sine function, cosine function, tangent of a function, cotangent of a function, secant function and cosecant function. We have seen that sin x and cos x are continuous functions, and tan x, tan x can be written as sin x by cos x. And you know that sin x is continuous and cos x is continuous, and quotient of two continuous functions is always continuous. But you know, in the denominator we used to have cos x. That cos x is 0 in case of 2n plus 1 into pi by 2. So in that case, cos x is not defined, except 2n plus 1 into pi by 2. In all other cases, sin x by cos x is always continuous. You have understood that about the algebra of continuous functions. Sum of two continuous functions is continuous, difference of two continuous functions is continuous, product of two continuous functions is continuous, and quotient of two continuous functions is continuous. So let us take up the next problem. It is given, prove that sin x plus cos x is a continuous function, and it is given sin x minus cos x is a continuous function, and then it is given sin x into cos x is a continuous function. You have to solve these three. See, you have to prove that sin x plus cos x is continuous. Very simple. You can just note down. We have already proved graphically that sin x is continuous and cos x is continuous. Two functions separately they are continuous. And we know from the algebra of continuous functions, sum of two continuous functions is always continuous. Hence, we conclude that sin x plus cos x is always continuous. Similarly, moving further, you have to prove that sin x minus cos x is continuous. How to prove that? We know that sin x is continuous and cos x is continuous, and the difference of two continuous function is continuous. Hence, sin x minus cos x is also said to be continuous. Then how to prove that sin x into cos x as continuous? We know that sin x and cos x are continuous functions, and product of two continuous functions is always continuous. Hence, sin x into cos x is also continuous. Hence, we can prove that sin x plus cos x, sin x minus cos x, and sin x into cos x, they are all continuous functions. So remember students, in the last class we have proved that all 6 trigonometric functions are continuous. So within that functions in which they are defined actually. So if you take up cot x is written as cos x by sin x. You know, cos x is continuous, sin x is continuous, quotient of two continuous functions is continuous. So cot x, which is written as cos x by sin x, is continuous. But remember, sin x denominator becomes 0 when x is equal to n pi. Except for x is equal to n pi, in all other cases we say that it is said to be continuous. I think you have understood how to solve this particular problem. So this is based on the trigonometric functions, continuity of trigonometric functions and algebra of continuous functions. We move on to the next problem. It is given that discuss the continuity of the function. It is given, discuss the continuity of the function f of x is equal to, it is given 3 if 0 less than or equal to x less than or equal to 1, 4 if 1 less than x less than 3, then 5 if 3 less than or equal to x less than or equal to 10. You have to discuss the continuity of this function f of x. So I think you have written f of x is equal to 3 if 0 less than or equal to x less than or equal to 1, and it is 4 if 1 less than or x less than 3, and it is 5 if 3 less than or equal to x less than or equal to 10. You have to discuss the continuity of this particular function. So how to prove that it is continuous? See, first we write when 0 less than x less than 1, f of x will be equal to 3. You know, it is a constant function. Since 3 is a constant function, we can conclude that f of x is continuous because we have proved that every constant function is continuous. Let us take when 1 less than x less than 3, f of x will be equal to 4. You know that 4 is a constant function which is said to be continuous. So, when x lies between 1 and 3, f of x is continuous. When x lies between 0 and 1, f of x is continuous. Let us take when 3 less than x less than 10. So, f of x is nothing but 5. It is 5. 5 is also a constant function. Hence, it is said to be continuous. Students, it is very clear. When x lies between 0 and 1, it is 3, continuous. When x lies between 1 and 3, f of x is 4, it is continuous. When x lies between 3 and 10, it is said to be continuous. Let us test the continuity at x is equal to 1. At x is equal to 1, what is f of x? See, f less than or equal to 1, it is 3 only. So, f of x is equal to 3. Let us take the limit. Limit as x tends to 1 plus f of x. 1 plus means it is right hand limit. Limit as x tends to 1 plus f of x. 1 plus means greater than 1. For x greater than 1, function defined is 4. Even if you apply the limit, it remains as 4. See here, at x is equal to 1, f of x is 3. That means f of 1 is also 3 because it is a constant function. So I conclude limit as x tends to 1 plus f of x is not equal to f of 1. So right hand limit is 4, but at x is equal to 1 it is 3. So we conclude that it is not equal. Hence we conclude that f of x is not continuous. So I conclude f of x is not continuous at x is equal to 1. I think it is clear for you. At x is equal to 1 it is not continuous. Let us take another point. Which is the another point we are supposed to consider? We have to consider x is equal to 3. So you find out at x is equal to 3. You find out at x is equal to 3. What is f of x? Please observe carefully. 3 less than or equal to x it is given. So x is equal to 3 means f of x should be taken as 5. So what is f of 1? F of 1 is 5. Let us take the left hand limit. Limit as x tends to 3 minus f of x. Limit as x tends to 3 minus f of x. What is 3 minus? Less than 3. For less than 3, what is the value of f of x? It is 4. So even if you apply the limit, it remains as 4. So what is your conclusion then? Limit as x tends to 3 minus f of x is not equal to f of 1. So at x is equal to 3, sorry, it is f of 3. It is f of 3. F of 3. So it is 5. And limit as x tends to 3 minus. If we take the left hand limit, it is equal to 4. So I conclude that f of x is not continuous at x is equal to 3. So x's points of discontinuity are x is equal to 1 and x is equal to 3. These are the 2 points of discontinuity. Think you have understood. So first of all, you have to write this. Please understand carefully. Look at the problem carefully. And when x lies between 0 and 1, f of x is 3. It is said to be continuous. And when x lies between 1 and 3, f of x is 4. Constant function, it is continuous. When x lies between 3 and 10, f of x is 5. It is a constant function, hence it is continuous. We have to check the continuity at x is equal to 1 and x is equal to 3. At x is equal to 1, if you take f of 1 will be 3. But when you take the right hand limit, it will be 4. So limit as x tends to 1 plus f of x is not equal to f of 1. We conclude that f of x is not continuous at x is equal to 1. Suppose if you take at x is equal to 3, f of x will be 5, f of 3 will be 5. When we take limit as x tends to 3 minus, that means when you take left hand limit, for 3 minus x less than 3, see that the function defined is f of x is equal to 4. So limit as x tends to 3 minus f of x is not equal to f of 3. Hence f of x is not continuous at x is equal to 3. So we conclude that the points of discontinuity are x is equal to 1 and x is equal to 3. I take up the next one. Discuss the continuity of the function. It is given f of x is equal to, it is 2x if x less than 0. 0 if 0 less than or equal to x less than or equal to 1. 4x if x is greater than 1. Please look at the problem carefully. So for all x less than 0. So it is given x less than 0, f of x is given, and also when 0 less than x less than 1, f of x is 0, and also when x is greater than 1, so f of x is 4x. See, let us write, when x is less than 0, f of x is 2x. You know, 2x is a linear polynomial. We have already proved that every polynomial function is continuous. So for all values x less than 0, f of x is said to be continuous. When 0 less than x less than 1, what is f of x? It is 0. 0 is a constant function. For all values between 0 and 1, it is said to be continuous because f of x is defined as 0. I write next. When x is greater than 1, f of x will be equal to 4x. You know, 4x is a linear polynomial. Every polynomial function is continuous. For all values greater than 1, it is said to be continuous. I think students, it is very clear. For all x less than 0, f of x is 2x. It's a polynomial, hence it is said to be continuous. For all values lying between 0 and 1, f of x is 0. It is said to be continuous. When x is greater than 1, f of x is 4x. It is a linear polynomial, hence it is said to be continuous. Let us check at x is equal to 0. At x is equal to 0. So let us take at x is equal to 0. What is f of x? F of x is said to be 0. F of 0 is said to be 0. Let us take the left hand limit. Limit as x tends to 0 minus f of x. 0 minus means, what do you mean by 0 minus? 0 minus means less than 0. Which is the function defined for less than 0? It is 2x. Apply the limits. 2 into 0 is 0. Now take the right hand limit. Limit as x tends to 0 plus. 0 plus means greater than 0. Which is the function defined for greater than 0? Function defined for greater than 0 is 0. When you apply the limits, it is 0. So what happens now? I conclude it here. Limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0. All values are 0. So what is your conclusion? So left hand limit is equal to right hand limit, that's equal to f of 0. So I conclude that f is continuous at x is equal to 0. Let us check at x is equal to 1. At x is equal to 1. See, at x is equal to 1, f of x is defined as x less than or equal to 1, it is 0. So f of 1 obviously it is 0. Let us take the right hand limit now. Right hand limit. Limit as x tends to 1 plus f of x. Limit as x tends to 1 plus means greater than 1. For greater than 1 function defined is 4x. So what happens when you apply the limits? 4 into 1 it is equal to 4. So I conclude limit as x tends to 1 plus f of x is not equal to f of 1. So right hand limit is 4, but at x is equal to 1, f of 1 has become 0. What is your conclusion? F is discontinuous or not continuous at x is equal to 1. See, in this problem, f is said to be continuous at x is equal to 0 because left hand limit is equal to right hand limit is equal to f of 0. But at x is equal to 1 it is not continuous or it is discontinuous because right hand limit has become 4 and at x is equal to 1 it is equal to 0. And hence we can conclude that the point of discontinuity is x is equal to 1. That is only one point of discontinuity, that is x is equal to 1. I think you have understood this particular problem. It's very simple. I move on to the next one. Next problem. Discuss the continuity of the function f of x is equal to minus 2 if x is less than or equal to minus 1, 2x if minus 1 less than x less than or equal to 1, 2 if x is greater than 1. These are the points given. So let us define one by one. When x is less than minus 1, f of x is minus 2. It is a constant function, hence it is said to be continuous. Further, when minus 1 less than x less than 1, f of x is given as 2x. Please see here it is given as 2x. 2x is a polynomial, hence it is said to be continuous. When x is greater than 1, f of x will be equal to 2. Now it is also a constant function. So minus 2 and plus 2 are constant function, hence we can conclude that they are said to be continuous. So what we have defined now, when x is less than minus 1, when x is greater than 1, both are constant functions, hence they are continuous. When x lies between minus 1 to plus 1, f of x is 2x, which is a linear polynomial, hence it is said to be continuous. I think you have understood. Let us start at x is equal to minus 1. I take x is equal to minus 1. What is f of minus 1 now? What is f of x basically now? It's minus 2. If we take f of minus 1, it will be minus 2 only. Now, we need to take the left hand limit and also the right hand limit. What is the left hand limit now? Left hand limit as x tends to minus 1 minus f of x. So what is that? Limit as x tends to minus 1 minus f of x. Less than minus 1 it is minus 2. Even if you apply, it will be minus 2 only. So right hand limit I take limit as x tends to minus 1 plus f of x. It is limit as x tends to minus 1 plus f of x. Minus 1. Minus 1 plus, it is defined as 2x. So it is 2 into minus 1. You will get minus 2. So what is your conclusion now? So limit as x tends to minus 1 minus f of x. Limit as x tends to minus 1 plus f of x is equal to f of minus 1. What is your conclusion? I conclude that f is continuous at x is equal to minus 1. So x is said to be continuous at x is equal to minus 1. Now we have to check at another point at x is equal to 1. At x is equal to 1. So at x is equal to 1, what is f of x? At x is equal to 1, f of x is 2x. So what is f of 1 now? Even if you put x is equal to 1, 2 into 1 is equal to 2. Let us take left hand limit. Left hand limit as x tends to 1 minus f of x is equal to limit as x tends to 1 minus. 1 minus means less than 1. For less than 1, it is 2x. 2 into 1, we get 2. And let us take RHL, limit as x tends to 1 plus f of x. What is that 1 plus f of x? Limit as x tends to 1 plus. 1 plus means greater than 1. For greater than 1, the function defined is 2. Even if you apply the limits, it remains as 2 as it is a constant function. So I conclude limit as x tends to 1 minus f of x is equal to limit as x tends to 1 plus f of x is equal to f of 1. See, all are equal. Those values are equal to 2. Hence, I conclude f is continuous at x is equal to 1. So, it is continuous at x is equal to minus 1, and also it is continuous at x is equal to minus 1 and plus 1. So, what is your conclusion? Our conclusion is there is no point of discontinuity. We conclude that there is no point of discontinuity for this particular function. I think you have understood how to solve this. I take another important question. Find all the points of discontinuity of the greatest integer function f of x is equal to greatest integer function x, where greatest integer function denotes the value less than or equal to x. You know the property of this. So greatest integer function 1.7 is 1, as you know. Greatest integer function 2.99, if you want, it is 2 only. 3.9999, it is nothing but 3 only. Greatest integer function minus 1.2, it is minus 2. Like that it continues. Suppose if you want the value of the greatest integer 0.999, it is nothing but 0. I think you have studied about all these things in the first PUC. Now we need to test the continuity of the function f of x is equal to x, that is greatest integer function x. So let us consider, let C belongs to R, where C is a real number. Where C is a real number. Let us consider C as a real number. We have considered a C in any value C, which is a real number, and we have to consider it is other than integer. Let us consider it as other than integer. We will take two cases. One, real number other than integer. Another one, when it is an integer. So if you know the basic concept of greatest integer function, we can easily solve this problem. So let us take at x is equal to c. What happens at x is equal to c? F of c. F of c is equal to greatest integer function c, which is nothing but c we can take. And we can take greatest integer function c. Limit as x tends to c, f of x is equal to limit as x tends to c, f of c. F of c is nothing but greatest integer function x, so it becomes c. What is your conclusion? Limit as x tends to c, f of x is equal to, we have got it as f of c. What is f of c? Greatest integer function c. Since limit as x tends to c, f of x is equal to f of c, what is your conclusion? So here we can clearly conclude that whenever c is a real number other than integer, f is said to be continuous. F is continuous. F is continuous means greatest integer function is continuous for all values of c where it is a real number other than integer. Let us consider case 2. I consider case 2. What is that case 2? Let us consider, let c belongs to z. That is, c is an integer. When we consider c as an integer, then what happens? So when we consider c as an integer, here we have to consider both the positive and negative values here. We have to consider both positive and negative values. So we can conclude that at x is equal to c, f of x is equal to greatest integer function x, which will be f of c will be obviously greatest integer function c. Now, when we take x tends to c minus f of x, we are taking the left hand. C, x tends to c minus f of x. So we are considering x. See here. Here comes the important concept. C minus, slightly less than c. Suppose if you take c as some value 2, slightly less than 2 means what is the greatest integer function? It is 1 less. As we can see, 2.99 means 2, 3.99 means 3, 1.7 means 1, 0.99 means 0. So it becomes 1 less. So when it is c minus, value of this greatest integer function will be c minus 1. It is not just c. It is c minus 1 because we are considering it as integer. So when we consider it as integer, so greatest integer function x will be c minus 1. I think you have to understand this concept. C minus we are taking. C minus means less than c. Less than c means its value should be c minus 1. It is, suppose if you are taking x tends to 2 minus means less than 2. What is the greatest integer function value? It is 1. Suppose when you are taking x tends to 5 minus less than 5. Less than means 5 means what is the greatest integer value? It is 4 only. Suppose if you are taking x tends to 10 minus less than 10. What is the greatest integer value? Then it is 9. So here it is c minus 1, but it is here c. So limit as x tends to c minus f of x is not equal to f of c. So f is not continuous where f is not continuous. Greatest integer function is not continuous where x is an integer, when c is an integer. But when it is a real number, it is said to be continuous. So I think you have understood how to consider this, and I think probably you remember this graph when you have studied in first PUC xy. Try to write the graph 1, 2, 3, minus 1, minus 2, minus 3, all 1, 2, 3, you have written all this. So how to write the graph here? Do you remember how we have written the graph in first PUC? It is like this. It is like this. So this is how we have written the graph for greatest integer function. That means at real numbers it is said to be continuous, but when we take it as an integer, it is said to be discontinuous. Whenever we take 2 you can see the open interval, that means to say that it is not continuous. At x is equal to 3 it is not continuous. Similarly, we can write the graph for all the functions, even negative values. So it's very simple. Similarly, you have to solve this problem. F of x is equal to x minus greatest integer function. Very simple. Again, this function is continuous for real numbers, but for integers. See, if you take left hand limit, c minus of c minus 1 you get. C minus of c minus 1 means it is nothing but 1. But for x is equal to c, it is not like that. So c minus greatest integer function c. Hence we conclude that it is not continuous. So this is how we have solved this problem. Please understand, greatest integer function is said to be continuous for all real numbers, and when it is integer, it is said to be discontinuous. Write the next problem. F of x is equal to x square minus sin x plus 5. And test for continuity at x is equal to pi. You need to test the continuity at x is equal to pi. You can do it easily. Very simple question. We need to test the continuity at x is equal to pi. So very simple. Let us take at x is equal to pi, pi square minus sin pi plus 5 we get. This is what at x is equal to pi is. To take limit as x tends to pi, f of x. Limit as x tends to pi, f of x will be x square minus sin x plus 5. So what happens now? It becomes pi square minus sin pi plus 5. So this is nothing but pi square plus 5, because sin pi is 0. So this is sin pi square minus 0 plus 5, we get pi square minus 1. So limit as extends to pi, f of x is equal to, what is pi square minus 5? Pi square plus 5 it is. Pi square plus 5, what is pi square plus 5? It is nothing but f of pi. So what is your conclusion? F is continuous at x is equal to pi. Think you have understood how to solve this problem. So very simple, find out f of pi, then find out the limit as extends to pi f of x, it will be clearly continuous. Think you have understood this problem, students. Very simple. Today we have solved few problems on continuity. So we have discussed initially sin x plus cos x, sin x minus cos x, sin x into cos x are continuous. Further we have solved few problems similar to the problems which we have solved in the previous class. And having very important, I have told you about the continuity of greatest integer function. Very important. If you know the graph, you can clearly prove it. Okay, it's very important. And afterwards, these type of problems were very easy. So I have already told you one problem will be definitely asked for 4 marks in the part E section from this continuity part. So that's all for the day. Thank you.